Good evening. Welcome to your class today. Thank you very much for taking your time to attend. So we're going to continue off from where we started off last time, right? So we're talking about finite automata with output. So we agreed, right, or rather we agreed, and we say that there are two automata that we have that contain output, right? So the first one, right, we have got the following. So there's one that is called a Mealy machine, and the other is called a Moore machine, right? So these two have got differences, but are more alike, right? So the first one, the Mealy machine, right? We start with the Moore machine, right? So number one, it has got output printed in state. Output printed in state. Whereas the Mealy machine has got output printed on transition. So output printed on transition. All right. So that is the first difference. So what do I mean? I mean to say, right, if we've got two states, right, let's label them Q0 and Q1, right, and we've got a transition between these two states. In Mealy machine, we have, say, this is a transition with an A, an output printed there. Whereas a Moore machine is going to have an output printed in the state. So we're going to have an A, and then Q1, maybe with a 0, right? So we have got a Mealy machine output printed on the transition, and Moore machine output printed on the state, right? So now, because of this, right, we say that for a Moore machine, right, say you have got an initial state Q0, which is with an output of 0. When we start the machine, we already have an output printed, right, before we get any input, because of the nature of its operation, right? So in this sense, the resultant is that we've got our length of output. Length of output is going to be 1 more than length of input. Is one more than length of input. Length of input. Right. So in this one we have length of input equal to length of output. Because you can start on Q0, not have an output. When you first have an input, which is your A, you can then print an output of 1. Right, so that is the two major differences between a Mealy machine and a Moore machine. Right. So we're going to look at how they interact later on. But first, let's look at the following. Right. So we have a Moore machine finite set. Then we've got an input string. Then we also have output characters. Then a transition table that shows for each input which state is reached next, and then an output table. So if we're given this Moore machine, right, it says what is the output of the machine? We draw in an input table, so let's pick a different color. We draw a table, right? In our table, we're going to have 3 rows, right? The first row is going to have the current, it's going to have the input, right? And then the second one is going to have the state, and the third one is going to have the output printed. So output printed. So now, the first one, since the Moore machine, before you get an input, you're going to be in state Q0 with an output of 0, right? And then you then put your input into the table, right? So this is the summary table for a Moore machine. So you're going to have A, B, A, B, B, B. And then if you're in Q0 and you encounter an A, you go to Q1, and Q1 is got an output of 1. If you're in Q1 and you encounter B, Q1 and you encounter B, you go to Q2, and Q2 is got an output of a 0. If you're in Q2 and you encounter an A, right, you go to Q0. Q0 is got an output of 0. If you're in Q0 and you encounter a B, you go to Q2, and Q2 is got an output of 1. If you're in Q2 and you encounter a B, you go to Q2, and then it will have an output of so this would be a B. This is supposed to be Q1. Sorry, with the B, it's supposed to be Q1. So Q2 and Q2 have an output of so this is Q1. Sorry, with an output of 0. And then when you're in Q1 and you encounter B, you stay in Q1 with an output of a 0, like that. So this becomes the Moore machine associated with, or the summary table, or the resultant of putting this input onto that machine. Right, so that is how we go about it. If you find we've got 1, 2, 3, 4, 5, 6, right, inputs, then we're going to have 1, 2, 3, 4, 5, 6, 7 outputs. So that becomes the solution. Right, let's do one more. Right, if we have got the following Moore machine and we need to give an output there, so let's do it over there. We've got 3 rows. So number 1, number 2. So let's make them straight. So I've got 1, I've got 2, I've got 3. So I have input row, I've got state row, and I've got output row. Then I have these columns that I put in my numbers. And then I'm going to have this blacked out. Then this will be, we start in Q0. The input is A, B, 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 but A, B, 3 B's, A, B, B, A, and B. So if you're in Q0, you're going to have an output of 1. If you encounter an A in the Q0, you go to Q1 with an output of a 1. If you are in Q1 and you encounter a B, you go to Q2 with an output of a 0. If you're in Q2 and you encounter B, you stay in Q2 with an output of a 0. If you're in Q2 and you encounter B, stay in Q2 with an output of a 0. If you're in Q2 and you encounter an A, you go to Q0 with an output of a 1. If you are in Q0 and you encounter B, you go to Q1 with an output of a 1. If you're in Q1 and you encounter B, you go to Q2 with an output of 0. If you are in Q2 and you encounter an A, you go to Q0 with an output of 1. Then Q1 with an output of 1. So this becomes the output. So it's 1, 1, 3 zeros, 1, 1, 1, 0, 1. So 1, 1, 3 zeros. So it's 1, 1, 3 zeros, 1, 1, 0, 1, 1. So option 3 becomes the correct solution there. So that's how we go about with the Moore machine. Right, let's do another one for the Moore machine. So given the machine below, each one of the following represents the output that would be printed if the machine were fed the input BAAB. So looking at this, we've got how many 5? So we've got 1, 2, 3, 4, 5, 6 input, state, and output over there. So if we've got this blanked out, we start in Q0 with an output of 1, and then we've got B, A, B, B. And then if you're in Q0 and you encounter B, you go to Q3 with an output of 1. If you're in Q3 and you encounter an A, you go to Q1 with an output of a 0. If you're in Q1 and you encounter an A, you go to Q3 with an output of a 1. If you're in Q3 and you encounter a B, you go to Q2 with an output of a 1. If you're in Q2 and you encounter anything, you stay in Q2 with an output of a 1. So that becomes the final one. So it's 1, 1, 0, 1, 1, option 3. Right. So that's much about it with the Moore machine, right? So if you look at the Mealy machine, we said we have a finite set of, so this was finite set of Q's states, alphabet of input letters, then our possible output characters, and the pictorial representation. So this is now Mealy machine. Right, by small circles, the directed edges transition between the states. Each edge is labeled with a compound symbol in the form of input-output, where I is the input letter and O is the output character. Every state must have exactly one outgoing edge for each possible input letter. With the edge you travel is determined by the input letter I, while on the traveling edge you must also print out the output character. So if we're given this, so right. If we look into this, we'll see that we cannot form a summary table here because the summary table was given, or we could do the summary table because the output was based on each state. It was for each state, right? Output was state dependent. So now, if we are saying here now output is transition dependent, we can have an A with an output of a 0 and an A with an output of a 1, right? So we do not want this, we don't want to have such, how can I put it, such ambiguity. So we cannot have a transition table that we have input, and then we can say yes state, right? But output would be such and such, right? So the output is not tied to a state or to something that is stable. So we cannot create that summary table here. But what can we do, right? If you're given a Mealy machine and want to accept that, so we can pass it through by through. If you encounter an A, if you start in Q0, if you encounter an A, you print out an output of 0, so it's 0, and you go to Q1. You are now here. If you encounter an A, you go to Q3 and you print out a 1. And then if you're in Q3 and you encounter an A, it's an output of 0, remain there Q3. If you're in Q3 and you encounter B, you go to Q0 with an output of 1. If you're in Q0 and you encounter B, you print 0 and you go to Q3. So this will be our output. That will be our output. Right. But next, we can then have which one of the following is a machine that performs a parity check on the input string. That is, the output string ends in 1 if the total number of bits. Right. So which one of the following is a machine that performs a parity check on the input string? That is, the output string ends in 1 if the total number of 1 bits is odd, and 0 if the total number of 1 bit is even. So the front part of the outgoing string is ignored. The front part of the outgoing output string is ignored. Right. So they're saying we're given both Mealy machines and Moore machines and say the front part is ignored. So if, say for this, if the output was 1, right, we're going to ignore that, right? So now we want to check what is the check that we're doing if number of ones is odd, then print 1. If even, then print that. So in any case, if the total number of ones, right, is even, then we know, or we have 1 at the end and the total number of ones is even, then we know that it is the machine that we're looking for. Or alternatively, so there are two ways, and this is how I understand the question, right? If you have got an even number of ones, right, and there's a 1 at the end, then that is correct. But if you've got an even number, if it accepts a word with an even number of ones, right, and 0 is at the end, then it is not correct, right? So let's check this one. So if we've got this one, if you've got a 1 it goes there, right? If you have another one, so if you have, say, 1, 2, right, it goes, it prints out a 0. So let's pick a word. So say 1, 1, 1, 1, 0, 1, 1, 1. So this is 4, 7, 1. So if I've got a 1, I have a 1 over here. So let me use a different color for the purposes of that. So I've got a 1 over there. So I'm in this state now. If I have another 1 and the printout is 0, if I have another 1, I print out a 1, another 1, I print out a 0, I print out a 1, then a 1, I print out a 1, and then a 1, I print out a 0, 1, I print out a 1. So we have an output printed of 1, 2, 3, 4, 5. Right. So it says, and we say that that is the output string ends in a 1 if the total number of bits in the string, 1 bit in the string, is odd. So the output, we are not looking, if we have got an odd number of bits in the input, then just to correct what I said earlier, if we've got a total number of odd 1 bits in the input, then the output here is supposed to give you 1 in the output, no matter what it does, as long as there are odd number of that, it should give you 1. Now, if I have got 1, 1, 1, 1, if I had ended here, it was going to give me 0, right? And you see that here I've got odd, it gives me 1, even it gives me 0. So this is potentially one of the correct solutions, okay? Then let's look at this one, right? This is 1, 0, and then 0 with an output of 0 there. So let's have 1, 1, 1, 1, even number of 1. So to have 1, it would be 1, 1, it would be 0, 1, it would be 1, 1, it would be 0. So here is going to be 1, here is going to be 1. So this is also a potential one. I'm going to come and revisit it, right? Then if we have got this is wrong, right? Okay, cool. It's not totally wrong. Let's look it with a fresh eye. So we're saying if you're in Q0, you have a 0, right? You ignore the first one. But if you encounter a 0, right? So this is odd, and this is even. So odd number of letters, it's giving you a 1. You can have 3 zeros, it will give you a 1, okay? I can have 0, 1, 0, it will give me a 1. I can have 0, 1, 1, it will give me a 1. So this one is incorrect because it only gives an output of 1 to odd numbers with odd or inputs with odd length that is odd, right? But if you look at this one now, number 4, so we're saying that if you read a 0, right, you go to something that prints out a 0. If you read a 1, you print out a 1. But if you read another 1, you print out a 0. If you read another 1, you print out a 1. Right. So I can then have, say, for example, I've got a 1, and I have a 0, and I have another 1. Right. So I end with I've got 2 1s, but I print out a 1 at the end. So that is not correct. Now let's come back to these two. Which one is the genuine one and which one is not the correct one? So if I have, say, for example, 0, 1, 0, I would say if I have 0, I stay there. I have a 0. If I've got a 1, I go. I have a 1. If I have a 0, if I have a 0 at this point, I stay. I print out a 1. Right? In which case here, if I have a 0, 1, 0, if I have a 0, I print out a 1 here. If I have got a 1, I print out a 1 there. If I have got a 0, then I print out a 0 there. So this one is wrong because you have got an odd number of 1 in the input, but it's printing out a 0 at the end, whereas this one is printing out a 1 at the end for each odd number. So this will be the correct solution. All right. So now let's look at converting the Mealy machine into a Moore machine. Right, so initially we said that a Moore machine has got the following properties. Right, we say that we have got Q naught inside and the output printed there. Right, if we've got this set up, how do we go about doing it? We do the following. Right, we do the following. So with an A to Q1, right, so if I have got a Moore machine that behaves like that, right? So if from that I go there, it means that with this transition is the one that is going to that output. So I translate, right, QX and then output of whatever one, right? So we say that incoming transition gets the or let's rather put it this way. Sorry. Let's rather put it this way. State gives output to incoming transitions. So if I've got an A and a B coming in there, right, and I've got Q with an output of 1, then this is going now to be equal to A1, B1 with an output of with the state Q. Right. So this is how we convert from a Moore machine to a Mealy machine, which is pretty easy. Right. The next one, then we need to do Mealy to Moore. So this is where the complication can be found. Right. If we're doing Mealy to Moore, right, we know that we have an A1 and it goes to Q2. Right. We distribute these to where it's going. So transition gives output to states or to destination states. To destination state. Right. Now, if we look at this, we can have the following. If you've got an A and a 1, and then Q2, we're saying this will become A, Q2, and a 1, which should be relatively simple, right? But there can be variations now. If we say, for example, if we do the following, if I've got an A coming with a 1 and a B coming with a 0 from that side, what would this one take? Right, so if we have got this nature, first we split it into 2, so this is Q1. So we split Q1 into 2, right? Q1. So this one we have an index of 2, this one we have an index of 1. So the first one will be responsible for accepting the state where we have got a 1. The second one will accept where we have a 0. Right. So we're saying the one with an A goes to that and the one with a B goes to that. So we've broken down the state into 2 identical states, which have got that print out 2 different outputs. Right. Now, let's look at another variation. If we've got these 2 coming in, Q1, and we've got then A, say, for example, 1, and they all go to Q2. So A1, B1, right, like that. So what we'll do normally is we'll say Q2 is fine. Okay. We say to split out Q1. So we've got Q1, 2, and we've got Q1, 1. And then this is an output of 0, this is an output of a 1. I think I reverse the polarities there. 1 and an output of a 0. So within an A will take you to that, and the B will take you to that. And then now we have got a state Q2, right? Because we have a transition there. So ensure that all these states or all these quasi-states are going to have within A and within A. They both live within A and go to their destination state within output of a 1 like that. All right. So that is how we go about the distribution. So now let's go to the actual questions. So firstly, they say put this AB into the Moore machine. What is the output of the machine? Output of a Moore machine gives you 1 more than the output of a, or more than the input. Right, so we've got input, we've got state, and we've got output. So we're gonna have our columns, and then this is the initial one at Q0 with an output of 0. Then we've got A, B, A, B, 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 A, B, B, and then B. So in Q0 with an A, you go to Q1, right, with an output of 1. In Q1 with an output of a B, you go to Q1 with an output of a 0. And then A, we've got an output, if you're in Q1 engine count an A, you go to Q0 with an output of 0. If you're in Q0 engine count a B, you go to Q2 with an output of 1. If you're in Q2 with an output of, if you're in Q2 and you encounter B, then you go to Q1 with an output of a 0. Then if you're in that engine counter B, you stay in Q1 with an output of a 0. So this becomes the output, say 0, 1, 1, 1, 0, 0. Right. Then next they ask us to convert the Mealy machine to a Moore machine. Right. If we are going to convert the following, so let's first have our initial state, which is Q0. Right. So we look for the potential problem areas. Look for the potential problem areas, right? So we've got Q11 and Q12, so those are split ones. Q2 is not split, so we can give it as it. So Q2 distributes its inputs to or outputs to B in the 1, and then also distributes to Q1, right? So Q2 to Q1 goes with a B, right, with an output of a 0. And then if you continue doing that, you have got a B with an output of a 0. And then if you are from Q0 and you encounter an A, you go to Q1 with an output of a 1, Q1 with an output of a 1. Then, so we go with, you're saying from Q0 to Q1, go with an A with an output of a 1. And then we need from Q1 to Q0 with an A, Q1 to Q0 with an A with an output of a 0. Then over here, over there we find that Q0 has got an A and a B, this one has got an A and a B, this one has got a B, but not an A. With an A we go back to that. So with an A we go back to 0, like that. So this becomes the finite automata for the Mealy machine given that Moore machine. All right. Then the next one For the following, Mealy machine must be converted to a Moore machine. So if you want to convert this, we first identify the problem ones. So here we've got incoming with the 1 and incoming with the 0. Here incoming is 1 and 1, here incoming is 1 and 1. So this is the only problem one. We need to split into 2. So we've got Q naught, right, which is the input. The ones that are coming into it, we've got a 1 incoming, we've got 1 over here, 1 over there. Then we go to, so Q1, and then we do that, give an output of 1, then this becomes A and B, and then with that, and then we want to split Q2, right? So Q2 is the same one. I need it to have an output of a 0. The other I need to have it an output of a 1. Right. Now, from Q0, you don't go to Q2, that one. From Q0, you have an A, B, and U. Then Q1 give A1. Right, so Q0 is 1, Q1 is 1. Let's find B with the 1, B with the 0. So B with the 1 can go to that B. And then right, and then if we've got that, we have got if you encounter an A, and if you encounter an A over here, this one goes back here. Right? Then Q1, if you encounter B, go there. If you encounter an A, you go there. Then Q2, the one with 1, the one with the output of 1 goes to B. Right? But then access to B from to Cairo. Right, so if we want to look at this in that light, we're saying Q1 is going to Q2 with the Q2 with the 1. So we need to make this a 1. And then Q2 not receives its support from itself. Then if you're in Q2 1, but if you're in Q2 1, if you've come to Q2 and you've maintained your 1, then what you can do is you can exit. Q2 1 can go to Q0 with an A, and you can also so there's an A, and we also found number Q2 also needs to have an A going out to Q0, A, Q2, and then B stays here. Right, so B, it stays there. Right, so this one has got an A in the B, this one has got an A in the B, this one has got A in the B. Right, so that becomes the Mealy machine of the following finite automata. So that is how we go about it, and I'm gonna stop here for today. You can find some more questions in the past papers that you can try some, and if you can send them through, then I can be able to assist you in the attempts that you've done. Right. So thank you very much for attending. Oh, okay. So Q2 with a 1, we said with an A, you go to Q1. With a B, if you're sitting with B, then you go to this one. Right. And if you're sitting in this, if you have an A, right, you go there. With a B, you stay there. So we should be fine. Right, cool. So thank you very much for attending. Enjoy the rest of the evening. From me to yourself, it's a pleasant good night and happy weekend.